Hey guys, so for this video we're going to be looking at formatting output. And the reason it's important is because it doesn't necessarily matter if you have the correct answer if it's not readable and easy to understand. You know, imagine if somebody hands you a piece of paper and it's all jumbled everywhere. It might be clear for them, but to you and everybody else, it looks like hieroglyphics. So that's why it's important to format output. That way it's easy for you to read one, the user, your boss, your coworkers, so on and so forth. So let's go ahead and get started. And before we start, we do need to add a new library, and this is just pound include io manip. There we go. And it just stands for input output manipulation, which makes sense. Without that library, everything we're going to be doing here today wouldn't work, and your computer will just yacht you. So make sure you have that included first. So first thing, let's just do a little simple cout statement. Hello world, just like before. We have an end line, and let's run this just so we can see what it looks. Make sure we remember. And as you can see, it's like right up against the little wall. And as far as we've known up to this point, the only way to add space is if we physically insert the space in between the quotes, and we'll see it appears. But that's really redundant and even looks really horrible, and it'd be pain to count all those spaces every time. So conveniently, there is a function we can use, and it's set width, just set w. The w just stands for set width. And let's do hello world again so we can notice the difference. Okay, so what we put inside these inside the parentheses is any number, and that integer number will put that many number of spaces for us. So let's do 20. And then I'll continue to explain it more. There we go. There we go. So you can see it pushed it over. We didn't have to type that many spaces like I did before. It actually looks nice. It's really easy. It's easy to type, easy to remember what it does. By default, set width always pushes things from left to right, and that's just because we read from left to right, so it's natural that way. You can change it if you wanted to go the other way though, but just remember, by default it always pushes it to the right. Another thing to remember is set width only affects things immediately adjacent to it. So for example, let me put another word in here. Let's just do, I don't know, test, first thing that came to mind. There we go. Let's close this guy and let's rerun. So as you can see, there's no spaces between the word world and test. It just smushed together, and it still put the spaces at the beginning for us. So if we would like to put space between the word world and test, we could put another set width, and let's just do 20 so it looks the same. There we go. So now I'll put another 20 spaces between those. So make sure you remember that, is that set width only affects things immediately adjacent to it. It does not propagate to an entire cout statement. So you have to put set width everywhere where you would like it to put spaces for. And remember, for all the things we're doing today, we always put them in between our cout statements. They're always in line with the statements, just because cout is our print statement to actually show on the little black console window we see. So it makes sense that all these input output manipulation functions would go inside cout, because cout controls our output. So that was set width. Next one I want to show you is a set precision and fixed, and those just control the number, the level of accuracy for a variable. So let's go ahead and make a variable and make this pi, and let's just do 3.14159.265. There we go. Oh, that's supposed to be 3. There we go. So say we do need that many decimals for accuracy, that's fine. We could just use that if we need to do any type of physics problem or math problem. But let's say we only need 2 significant figures. We don't want to make another variable called double pi 2, then just put 3.14. Instead, there's functions that we can do. So let's do cout fixed, and then cout set precision. There we go. And inside the parentheses goes any integer number, and that number tells you, well, tells the computer how many numbers should appear after the decimal point. So let's just do 2, and then let's see out pi, and it should be 3.14. Again, can't spell. There we go. So let's try this now. 3.14. Now let's say we need to go to any higher level accuracy, and this does round. So let's see, 1, 2, 3, 4. The last number should be a 6. Yep, and it is. And if you look at it, it goes 3, 1, 4, 1, 5, and now it looks at the very next number, 9. The 9 causes the 5 to get promoted to a 6. So just like in any math physics classes, when we look at significant figures, you always look at the very last number before you print, and say if it's 5 or greater, you promote the number. If it's less, then you leave it alone. And C++ follows that exact same logic for significant figures. Now, one thing to realize is when you type cout fixed and set precision and put whatever number in there, that actually does propagate through your entire program. So if I make another variable, just double rand, and do like 1, then whatever many decimal points, and if I see that out, it'll also only have 4 decimal points. So let's do rand. So unlike set width, this actually does propagate through the entire program. There we go, and you can see they both have the exact same number of significant figures. So all you have to do is type cout fixed and set precision once, and it's good for your entire program. And then you can turn those off as well if you do need a higher level of accuracy, or you can just change the number in here if you don't want to turn them off, and that way you can control the exact level of accuracy you want. I would recommend always doing that. Now the last function I want to show you guys is set fill. So let's bring up our set with hello world again. We'll do 20 hello world. We got n9, and if you remember, it just had the 20 units of space right before it. Well, what if we could fill that with like a star? Well, we can. Just set fill, and inside the parentheses you put whatever little character you want it you want the white space to be filled with. So let's try a star. And remember, characters are always single quotes, and a character is always just one single thing, one single representation. And anything that's 2 or more is a string, so we have to put it in quotes like that. So let's go ahead and run this. And look, it filled all the little spaces up with stars. And you can change that to anything, so let's try dashes. There we go. Nothing but dashes. Those are the 3 biggest input-output manipulations for C++. I will include a link in the description that goes to C++ website. They include a great detailed explanation of all these functions and some great examples if you want to look at them more in more detail, or if you just need a refresher. But thanks for watching as always.